Welcome back to the second video on segmentation. In this video, I'm going to talk to you about how to conduct segmentation, specifically cluster analysis, within the Tableau environment. First things first, let's discuss what Tableau does under the hood to conduct cluster analysis. Tableau uses a certain kind of clustering called k-means clustering, which we know from the previous video to be the more efficient kind of clustering algorithm. It is critically important to scale your data to prevent variables from getting overweighted based on their scale alone. Tableau uses something called min-max normalizations to ensure all the variables are on the same scale before clustering them. The number of clusters is determined by the Kolinsky criterion that Tableau uses. As you well know, the decision number clusters should preferably be informed by domain knowledge, but in the absence of that, Tableau offers us a nice automatic recommendation of what's the most desirable number of clusters. With that said, let's get started. Let's look at a couple of ways of conducting cluster analysis within the Tableau environment. We're going to begin by looking at the Superstore data. We're going to segment the Superstore data from Tableau that comes with Tableau. Specifically, we're going to we're going to cluster Superstore customers based on average profit and average sales. And then we're going to compare the two segments generated in terms of discount and number of customers. I'm going to go over now to Tableau. Here's the Tableau environment. If you don't already have this installed, you need to get a copy of Tableau Desktop and obtain your product keys. If you don't have if you're on the trial period, you can obtain your product keys and click on Manage Product Keys. And this way you'll get a year of license using your student keys that Tableau provides. Okay, let me click on Sample Superstore from the bottom left-hand corner in the blue ribbon, which will load up the Sample Superstore dataset. As you can see, this is this familiar Sample Superstore dataset that contains information about transactions that people have had with the Sample Superstore. This includes information about the order, the date, ship date, information about the customer, their location, and finally, we have information about the transaction sales, quantity, discount, profit. What we're going to do here is we're going to cluster our data based on average profit and sales, defined by where average is defined by the customer. So we have here 9,994 rows of data, but many of these rows may refer to a single customer. So even a single customer may buy multiple things, and therefore there are fewer number of customers than number of rows in the data. Let's call this our cluster, let's say Superstore cluster. Let's say cluster, let's say Superstore cluster. And with that named, let's go in and start building out our cluster analysis for the Superstore data. I'm going to get started in the beginning. The first thing I'm going to do is I'm going to go and group by folder, just because the Superstore data is organized by data set, and that isn't intuitive to me. Now we can focus on the variables that we want to cluster here, which are sales and profit. Now, before I proceed, let me explain to you the process that Tableau uses to conduct cluster analysis. This is a bit non-intuitive. Tableau begins with a scatter plot, or wants the user to begin with a scatter plot, and then from the scatter plot derive a cluster analysis. Even if you've got multiple variables, you have to begin with a two-variable scatter plot before you can go on to build out a cluster analysis. So I'll drag profit onto columns, sales onto rows, and that's going to give us a scatter plot. Well, not really. We have one dot in our data. We'll resolve that in just a minute. Let me first make this profit and sales to be average, and then we'll resolve the issue of the fact that we have only one dot. Now, you may already know why this is happening. We only have one mark on our data because right now our data is aggregated on the global level. So we have the average profit of all our customers and average sales of all our customers. All our transactions, excuse me. Now, what we want to do is we want the level of detail to be a customer. So every dot would represent a given customer. So we'll drag customer name onto detail. This will give us as many dots as our number of customers. Let's confirm that. I'll first go back to customer name and hit describe. Under here, you can see customer name includes the names of 793 customers. You'll also notice now, if you look in the bottom left-hand corner of your screen, circle that or mark that, it says a support mark. Let me try that one more time. You'll see it says 793 marks. This is not really working out for me, but hopefully you can see where the red rectangle is right by it is a indication of how many marks we have in our scatter plot. Now, just to make the scatter plot look a little nicer, easy on the eyes, I'm going to go with solid circles and scale the size down to minimize the level of overplotting we got going on here. Now, an obvious question that might cross your mind is when you build out the scatter plot, which is an ingredient for cluster analysis, should you go with what should be on the x-axis, what should be on the y-axis? It really doesn't matter. It doesn't matter what you put on the x and y-axis because this is merely an intermediate step for us to get to the end goal of the cluster analysis. So whatever you choose is fine. You can swap these pills and you can get a different look, and that's fine. Now that we have done our first step, let's go on to our second step of creating the cluster analysis. For that, you'll go to the Analytics tab in the top left-hand corner, and then look for cluster. Drag cluster onto your canvas. As you do that, you'll see cluster popping up. If you drop it anywhere, like on cluster, you'll get a cluster analysis. That's it. Tableau has already run for us a cluster analysis. It's that easy, that simple. And so as soon as you drop profit and sales on here, you get your cluster analysis results coming out. So we have basically, as you can see in the visual, it looks like we have 3 clusters. Cluster 1, 2, 3, and also you might notice something new showing up here. Let me highlight all the things. There's something that are new out here. We might see this box showing up. This indicates to us we're clustering using these variables. Under number of clusters, says automatic. That means Tableau is generating number of clusters using the equivalency criterion. We can see visually there are 3 clusters, so we know that it's gone with a 3 cluster option by default. This you may not have noticed, but there's a new pill in the marks card called the clusters pill. This was generated whenever we brought the cluster model in. It created a pill called clusters. This variable stores the cluster membership for our data. Okay, so let me X this, close this clusters window. Don't worry, it won't ruin our cluster analysis. Next, I'm going to go to the clusters pill, and let's kind of drill down a bit here to see what's in this pill. In here, we have options like edit clusters and describe clusters. Before describing clusters, let me click on edit clusters. So you can then see that window that we just closed, we can always get back by clicking on edit clusters. Going further, let's go back here and say describe clusters. This pulls up a window that tells us a bit more about what we have clustered. Let's go over this output. So first things first, we're using profit and sales for clustering. Our level of detail is the customer name, and we have normalized or standardized our data. We know we're using min-max normalization, the default for Tableau. We have determined 3 clusters as being optimal based on equivalency criterion. We have 793 customers, hence 793 points. It tells you some information here about the between group sum of squares and within group sum of squares. We quite naturally like to see the within group of sum of squares to be smaller than the between group sum of squares. Some people look at this ratio in figuring out, again, what is the optimal number of clusters to go with. But we're not going to worry about that here. Furthermore, you can tell here clusters 1, 2, and 3 are basically, very different in terms of their number of items, which in this case is customers. We can also tell from looking at these numbers that cluster 1 by far is, see some colors out here, or stamps maybe. So cluster 1 is not such a good cluster for profit and sales. You can see that maybe cluster 2 is a little better, but really we love cluster 3. Because cluster 3 is making us a lot of money and a lot of sales. Unfortunately, we don't have a lot of customers in this particular segment. You can learn more about the output from going in here to the Nova table and describe clusters. We're not going to worry about that here. Let's go back here. And I'm going to close this now. Now, the next step is we have conducted the cluster analysis, but we have no way of saving this variable. We have not saved this variable yet. So our next step is to save this cluster pill. I will switch the tab on the top left-hand corner to data. And then I'm going to drag this over. Now, in previous versions of Tableau, when you dragged it over, it ruined your clustering or ruined your scatter plot. So I recommend then, if you're kind of old-fashioned like me and maybe you're using an older version of Tableau, to try and get a copy of clusters. To get a copy of a pill in Tableau, you typically press down on Command on a Mac or Control on a Windows machine. With that key pressed down, so at this point, my left thumb is on the Control key because I'm using Windows, or you could put it on Command on Mac. And with that key still pressed down, I'm going to go to my mouse, and that's my cool mouse. And I'm going to drag this clusters pill over to the dimensions section of my data pane, and drop it there. And it's only now that I'm going to let go of my left thumb of that Control key. Now, Tableau's provided a default name for this. It's called this customer name clusters. I'm going to call this customer segments. So I'll rename this variable. You'll notice that customer segments is a grouped variable. We know that because of the icon right next to it. Okay, that's a lot about. We've conducted a cluster analysis now, and our customer segments is a group. Let me click on Edit Group out here to see what's in the different categories. So clusters 1, 2, 3 are listed out here, and you can see cluster 1 has a paperclip next to it to indicate grouping. And if you click on that caret, you see who are the customers part of cluster 1, cluster 2, and cluster 3 is a very small group of customers we know because it's a small cluster. So just to kind of show what we can do out here, I'm going to rename these as segment 1, segment 2. So you can right-click here, rename segment 2. And this way we have our own customer names for our cluster. They're not called cluster 1, cluster 2, cluster 3, cluster 3. Okay, great. And then hit apply, and now we have our kind of variable customer segments we're going to use for doing the key part now. Now that you have the clusters defined, let's compare the clusters or segments based on some variable of interest. So let's just call this Superstore. Yeah. I'll call it Superstore profiles, which is basically comparing our segments based on some variable. I'll drag customer segments over to, say, rows, because we want to, compare those segments on something. What are we going to compare it on? Let's see. Actually, let's move it to columns. Okay. And so we have customer segments defined as a column pill now, and we're going to compare this based on two variables. One is discount. So I'll drag discount over to rows. And right away, we notice that we have discount as being some aggregation. We'll make that average. And next, we'll make this to be, we'll change the format of this to be in percentages so that our scale is more meaningful. Okay. So you can see out here, and I'll just color this a little differently because you know how I feel about colors being too vivid. Okay, and I'll make the pane a little bigger so we can see the segment 1, 2, 3 in the x-axis more clearly. Maybe even hide this field label for columns because it's redundant. All right, so you can see out here what is a discount we're giving to each of our customers. Segment 1 is getting the biggest discount, followed by segment 2, followed by segment 3. Now, if you think back to our segments, you'll recall that segment 1 was the segment that spends the least amount of money. So least profitable segment, and has the lowest sales segment also. Segment 3 consists of our best customers by way of profit and sales. Segment 2 is intermediate segment. However, we're giving our biggest discounts to our worst customers, segment 1. That's some food for thought for the Superstore company. Now, we can also bring in one more variable to view out here in different ways. So for example, you got this variable called customer name, right? So I'll drag customer name onto detail, and then I'll create a count of this variable. So we're taking dimension and we're kind of measuring it out, converting that to a measure here. So we have here count customer as our details card, and the marks card as a detail. We'll use this here either as a label. So you can have a label here that can tell you how many customers are in every. It's not correct. Is it? Okay. So I need to say measure count distinct. Excuse me. So every customer is treated as, it's not double counted then. So we have here count distinct customer name, and so what we get here is, so the column labels tell you how many customers are in every single segment. Alternatively, let's just say, you can always do this and say here n equal to, and you could also maybe move this down to, I believe, down to the bottom of the bar. So if I can move this to the vertical, there it is in the bottom right now. Kind of see now, and maybe even have this flip the axis here so it looks better. So I'm going to do this one more time here so we go horizontal format. This goes left. Okay. So here we have it. We have got sort of like a comparison of our segments, and oops, that doesn't go here. And you can kind of see out here that how many customers we have in each segment. If you're going to get really cute about this, there's another thing you can do. You could literally represent your bar thickness, have your bar thickness represent number of customers. So take a look at this. What if I did this, right? Now we have sort of like number of customers being represented by thickness of the bar. So you can see segment 3 has very few customers. Segment 1 has the most number of customers that are getting the sweetest deals. Okay, I'm going to go back to what we had before. This is, I guess, more typical in terms of representation. All right, so we've then constructed a simple, we've segmented our Superstore data into 2 segments and compared them by discount and number of customers. Let's move along to another example. I'm going to talk about, I'm going to use the fast food survey data here. This is data that was motivated or created by a study of health consciousness and fast food ratings for 2,000 respondents. Here's a quick overview of the survey itself. People are asked to rate their concern about health on 3 scales that range from 1 to 7. And then they rated 3 popular fast food restaurants on a 1 to 7 scale as well. They went on to then provide information about their gender, age, place where they live, and so on. All this is in a file called fast food that I'm going to pull into Tableau. So let's go. Let me go over to Tableau, and because we're in this sort of this worksheet view, to get a data set, we got to go back to our starting page. So click on the Tableau icon, the top left-hand corner, and go back to our start page. From there, I happen to know that our fast food file is a CSV file. So click on text file here to pull up fast food. So fast food is now part of our data, is part of our view. We've got here, it says 13 fields, 2,000 rows. We have information about health 1, 2, 3. We have ratings of our restaurants, and we have demographic information also. Go to the sheet, a fresh sheet, and I'll call this fast food clusters. And now we'll go back in here, and what we can do here is let's review our data before we go any further. So Tableau does a pretty good job of parsing your data for the most part, but it isn't perfect. So it is going to make intelligent guesses about the formatting variable based on what it sees in the variable. Now, in our case, I don't think all these are correct. So gender, age, based on how we measured them, should be dimensions, not measures. Let's change some of those things, move those to where they rightfully belong. So I'll move age up to 2 dimensions, gender can move dimensions, and location can move dimensions. Let's just change the format is okay, I think, of these different variables. ID, I believe, should be, ID should not be a number. I'd rather have ID as being, like, it's fine. As long as the dimension, ID is fine where it is. Now you have the option, if you'd like to organize the data by the data source order, if you'd like to, like this. And I'm going to do just that. So ID is on top, and then, so whatever is the order in the data set is what you see in your dimensions and measures panes. All right, so let's next create our cluster analysis. So our goal here is to cluster the data based on their ratings of the health items. So people were asked to respond to 3 health consciousness survey items. We're going to cluster them based on those 3 items. So unlike our previous exercise, we don't have just 2, but 3 things to cluster. The cluster, we know our first step is to construct a scatter plot. Now, we'll use here again average health, average, although I don't think it's going to matter much here. Because our data is, every row is a separate observation, so it won't really matter. Nevertheless, let's stick with the same approach as before. So we're plotting average health and average health 1, health 2 on a scatter plot. We'll get the level of detail to be ID, because every ID is a unique identifier. I'm also going to make the shape to be solid, and then we'll kind of look at this and kind of wonder why we have this strange, scatter plot. You've no doubt seen scatter plots before, and this may look unusual to you. And I don't blame you, because this is an unusual scatter plot. It is typical for survey data, but otherwise unusual. It is unusual because you have these dots not scattered all over, rather than a nice right triangle format. And the spacing is very uniform, 1-point spacing. This is because our survey was such that we had people respond to a survey on a scale of 1 to 7. So they can only mark 1, 2, 3, 4, 5, 6, 7 for any of these items. So hence, in our, down here, we're only seeing these as our options. And really what's going on here is any given point as such is, you count the number of points here, you might say that, well, we have like, let's add these up, 3, 6, 10, 15, 21, 28 points out here. You don't have just 28 points, you have actually 2,000 marks. This is because we have a lot of overplotting going on. Let's see the extent of overplotting going on here by dialing down the opacity a little bit. So you can see now, when you go to 10% opacity, that means, what's normally one dot, it is going to take 10 typical dots to look like a regular, 10 of these dots to look like a regular dot. So you see then the top right-hand corner is kind of faded out much more now. Okay, and that's just visually kind of give you a visual sense of this. You can also go to density to get, I think, another perspective. So this again shows you the level of overplotting going on here in your data. Okay, all right. And that's just cosmetics, so we're not going to worry about it. Remember, the scatter plot is merely a means to an end. We're just doing this to get to the clustering solution. So let's go to analytics now. And you're probably wondering, we want to cluster using health 1, 2, and 3. Why don't I have health 3 in here? Well, we'll get there. Okay. You can only, to start the clustering process, you got to do a scatter plot. Scatter plot involves 2 variables. Let's do what you got to do here and do clustering using 2 variables. Now that we have our 2 variables in, we get 2 clusters out of it. Let's bring in now the 3rd variable. Click on data, go to health 3, drag health 3 over to the pane for clusters, and then set the scale of health 3 to be average. By default, we get 3 clusters. Let me see what I said in my note here about the number of clusters we want. We want to get 2 segments, okay? We want to get 2 clusters here. That's our goal here. So let's specify the number of clusters now. We'll put a number here. The default, it's automatic. That's 3. We can see because there are 3 clusters indicated on Tableau. If you type in 2 here, it's going to give you 2 clusters. As simple as that. So we're using health 1, 2, and 3 to get a 2 cluster solution. Okay. And I'm going to close this window. Now, again, remember, if you want to get that window back in, you can always do edit clusters and get that back. Now, I'm going to go and describe clusters to take a look at what our clusters involve. You can see we have sort of like 3 variables going in. You can see the level of detail is the ID, because every respondent is a different ID. And normalized by default, we have 2,000 points and 2 clusters emerging from it. We can learn a bit about the between and within sum of squares. Importantly, we can also look at our 2 clusters. So cluster 1 has 1,081 items or respondents in it and has some health 1, 2, and 3 metrics. Now, bear in mind that lower the value of any of these health measures, the less, all else being equal, the person cares about their health. So low numbers represent, sort of a nonchalant view on health, while high numbers indicate a lot of concern and care about one's health and well-being. So you can tell that cluster 2 really cares about their health. Cluster 1, not so much. So keep that in the back of your mind, because we're going to assign labels to our data accordingly. So let's first save clusters by moving it over to the left. Again, do that keep control press down and drag and drop clusters. And that being said, I will say that if you just drag and drop with newer versions of Tableau, it doesn't create an issue. But then again, I've been using Tableau for a long time, so I'm still stuck in the old ways. Okay, so we're going to say out here our name of our object is our name of our variable is fast food segments. You notice how that name just kind of disappeared. It didn't become editable. It's no longer editable. I'll rename that and say fast food clusters. And as before, you notice a paperclip icon indicating it's a grouped variable. So we'll go here and now edit the group, and we'll there have an opportunity to rename our two groups. We have segments. We're going to call it segment 1, the one that doesn't care about their health. let's say unhealthy. I don't say unhealthy. So um, low health concern. Say here high health concern. Okay. Just because you're concerned about your health doesn't mean you're, you know, healthy or vice versa. So you see out here we're going to low health concern, high health concern as our consciousness. Consciousness is a long word. I misspell it, so I don't want to type it in, but let's be more true to the survey. Consciousness. So copy that over. So we have this variable kind of figured out. Now, what we're going to do is we're going to examine the differences in health consciousness across the two segments. So let's say fast food. Fast food segment's health. So to compare them in terms of their health rating, which we've already seen a summary of, but let's get some sort of a graph here in place of this also. Move fast food segments over to columns, and I'm going to now need to move, because we have three measures out here, I can't just do this, right? I can't do this because we're going to get multiple graphs. So I'm going to go here with measure names and measure values instead. That's going to give us, oops, sorry, will give us a very crowded graph. We're going to whittle it down to the variables we want, which are all the health variables. Okay, so now we have here health 1, 2, and 3 in our kind of graph out here. And you can see if you want to just compare the segments in terms of each variable, we'll swap the pills. The bar charts look a little different now. And you can tell, hopefully, by looking at this, that our segments are different. We'll kind of color these as well by putting fast food segments, a copy of that onto color, and swapping the axes so we get a horizontal bar chart. Remove the card. And you can see kind of like in a bar chart here that, you know, in terms of health 1, the high health consciousness segment is indeed, you know, scoring really high. The low health consciousness segment is scoring low on that. So it does seem appropriate that we have labeled them high and low health consciousness. Wait a second. I should have converted the values to average. Let me do that. I wonder if our interpretation will change though. It doesn't. So we still have the same kind of information about high and low, which is high health consciousness is like high in health concern for all those variables. We'll fix this axis a little bit to make it so that it's 1 to 7 axis, and set tick marks to fix every one. It's a 1 to 7 scale. Okay, so here's one way of kind of doing this thing. We can do a fast food segments health, say 1, and we can repeat this thing. Let me clean up this chart a little bit. It's sort of like your graph showing you that how these two segments stack up in terms of their health consciousness responses. I'm going to duplicate this one, and if you wanted to make, let's say, a line graph, it might actually be cleaner. Let's try and do this. We'll first rename this chart to be health 2. Remember, your two sheets cannot have the same name. So you could also potentially create a line graph here. So to create a line graph, instead of having bars distinguishing the two segments, just take fast food segments off of here completely and convert the mark type to line. And it looks better, I think, if it's vertical. So I'm going to swap the axes here. And I can see, in a sense here, sort of health 1, health 2, health 3, and how they their contrast, sorry, how the two segments are contrasted based on their health concern. hard to tell what's blue, what's orange. So I'm going to move fast food segments, a copy of this to label, so we can label our segments, and move the graph wider also. There we have it. The graph looks a little better. Maybe the color should be changed as well. So let's see, the healthier people, I'm going to make them like healthy color. What's a healthy color? Maybe a teal, it's gentle. Not so healthy, I'll make them like low health conscious, and make them purple or something, or yellow. Or something. You can always make the lines thicker if you want to. Can make it thicker. Right, so it's kind of another way of contrasting again health consciousness, the segments based on the health consciousness. Okay. Let's go on now and see what else we can do to contrast the segments. So we're going to go on to examining our two segments based on, let's compare them based on age, gender, and location. So let's do that next. So we'll say fast food segments by age. And our age variable is right here. Age variable is, let's describe this one, has 5 levels to it, 1, 2, 3, 4, 5. Unfortunately, 1, 2, 3, 4, 5 are not informative. We can, of course, figure out what these numbers are from our survey. Go back there. So 1 is 1829, 3039, so on. Let me assign these sort of values. So 1 is this, and 2 is this one. So let me assign these aliases to our age variable by going to Tableau and selecting aliases for age. Right. So right click on our, I guess left click, just the down arrow, you get aliases option out here. And now this part is a little tricky. It seems simple enough when I do it here, but I know people on a Mac have a hard time. So you got to kind of gently click out here. And in my case, it was very simple. It just gave me a kind of option right away. But if you're in a Mac, you might have to find a way to the sweet spot to click just like gently out here, and then get that alias box be editable. Our aliases are done. Let me do aliases for gender as well. Let's take a look at what gender is in our data. Gender is male is 1, female is 2. Let's go and do that same exact aliasing for gender as well. So again, 1 male and 2. And we'll do the same for location as well. 10 aliases out here. 1 was Manhattan. 2 is 3 is Queens, and 4 is New Jersey. I'm sorry, I'm kidding. My home state of New Jersey. Okay, so now that we have this thing set up, we can start looking at fast food segments and compare them by, let's say, age as follows. So when you do is to get a graph that looks like a table looks like this, we're going to represent, we want to get a number for these in here, essentially how many people fit that category. So we'll kind of get ID onto detail, and then count the number of people that fit every category by saying measure and count. Say count, and count should be fine. Now drag count over to text, which is going to give us a number, a count of how many people fit in every single category. It's a little wider, it's better. Okay. And next, I guess, as such, the numbers, you can look at the numbers and see, which ones, the representation in segment of age groups. However, it might be easier if you could look at proportions then, what percentage of people in the high health consciousness segment are 18 to 29. So we'll go in and transform this variable here using a table calculation to make it a percent of total. We'll do percent total based on age, not fast food segments, which will then give us a graph, a table that looks as follows. We'll also go and maybe change the format of percentage to make sure the decimal places are eliminated. It looks nice that way. And lastly, that looks pretty good actually. We have your fast food segments, we have their health consciousness, and you can tell by looking at this a breakdown of the percentages. But if you want to add more color to this, you could by creating a heat map. So let me just drag a copy of count ID over to, so with Command or Control press down, I'll drag count ID over to color and make the mark to be a square. This will give us a heat map. I'm going to hide the card because it's redundant. And then let's use some different colors here to represent big and small numbers. I'm not a fan of the default blue, although I guess it does make sense. Let's go default brown. Let's go with brown and maybe step color, 7 steps. I don't know how that looks. All right, so maybe 7 steps here. So I'm using 5 steps because, you know, too many variations and too many shades of gray are hard for the human eye to tell apart. But let's go with 7 to better tell the story here. Okay. So hopefully you can take a look at this and learn something about the distribution. But before that, one more cosmetic improvement here with the alignment of the text horizontal. Maybe we make the text to be a little lighter in color, so make that 50%. Much more color, and then go 50%. We faded out the colors a little bit. So now you can see in a sense here that that in general, the low health consciousness segment, it tends to be older. The ones who are more concerned about their health based on survey tend to be younger, oddly enough, than those who are low in health consciousness. A very strange kind of result out there. Let's repeat this process for gender. So I'm going to duplicate this over and we'll get another graph out here. We'll do this for gender. Probably not do that location because it's taking far too long. And now we have age out here and replace age with gender. As I do this part, you know, a lot of things are going to break down, but don't worry, we'll fix them. So our count hills have gotten turned red because our table calculations got all messed up. We'll have to go back here and fix this by simply replacing age with gender. Okay. And that's it. So once we do the hard work in the beginning, you kind of realize that later on as this part becomes super easy to do. So you can see out here that your high health consciousness segment is largely women, and then the low health consciousness are, you know, there's a smaller proportion of women in the low health consciousness group, which I guess makes some intuitive sense. Okay, we can of course repeat the same exact task for location as well. Okay, so we've done this. We've done a comparison here by comparing the segments based on age, gender, location, age and gender, and we represent this as a heat map. Okay, let's go and take a look at one more example out here before we wrap up. We'll examine some data on nutrition facts. So there's a website called fastfoodnutrition.com that publishes nutrition facts for some items in a few fast food restaurants. The data is included in a file called fastfoodcalories.csv. Let me go ahead and kind of bring that data into Tableau first, and then we'll take a look at what our story is going to be. So fast food nutrition. So let's go fetch our data. Click on the start page, and it's in a CSV file. It's fast food calories is the data set. So fast food calories is in now. Here's what we have for our data. See how it's been parsed. We see here our variable F1 is an identifier, and we rename that to be ID. meaningful. And it's right now numeric. I'm going to make that, well, that's fine, I guess. ABC for restaurant, that's a string. String is good. All the numbers are numbers. Calories, total fat, saturated fat. Cholesterol are numbers. Vitamin A is a number, should be a number. Let's make that to be a number. Whole number. And vitamin C is all should be a whole number. Lastly, calcium should be a whole number also. And fix those variables. Let's go over now to our sheet, worksheet view. And we have fast food calories selected in the top left-hand corner, which is why that's the data set that's active in our view. So if you look in the top left-hand corner, we have this active. That's why the variables relate to fast food. Now, as you look at this, some things don't make a lot of sense to me. Vitamin A and C should be measures, or move them down, and calcium should be a measure as well. ID should be a dimension because it is an identifier. With that fixed, we have our data parsed the way we want it to be. So our goal here is as follows. We're going to go through all the different variables, specifically identifying, nutrition variables that we seem as undesirable. So, we tend to socially in the United States, we think of things with high calories, high saturated fat, high cholesterol, so on as being bad. So we're going to take all these bad nutrition facts or nutrition elements and construct a cluster analysis of it. We'll call this a health cluster, and we'll classify we'll alias clusters as being healthy and unhealthy. So we're going to do this for the variables calories, saturated fat, so on and so forth. But to begin with, we just want to use two variables. Oops. We just use calories and saturated fat to begin with. And we are going to use level of detail as being ID. Every menu item is a row of data, and that becomes an ID. Make the shape solid and the size all smaller, so it does all the fine. Okay, we don't care so much about the scatter plot. Let's go on to doing our cluster analysis. Drag cluster onto the canvas, and now we can safely create our clusters. Now, in my haste to get started, I didn't say average. I don't think it matters in this case much, but I want to be consistent, so I'm going to say average here everywhere. And I'm saying it doesn't matter much because remember, every row is going to be is individual observation or data. We're not grouping it by a bucket or a bin. So whether you do sum of an observation or an average aggregation or an observation, it doesn't really matter. But I want to be consistent, so I'm going to fix that. Now we have two variables in here, calories and saturated fat. We want to also bring in other variables into the picture, cholesterol, sugar. We have total carb, trans fat, and sodium. Total carb, trans fat, trans fat. Right? Apparently, it's good fat also. All right, and so I'm going to make everything an average now. Make this all the average. All right, so they're all average right now, which is great. And we've been told to look for two clusters. So it's a good bad type of dichotomy. So it turns out automatic choice is 2. We could say 2 out here, it wouldn't make any difference. And this is kind of useful though to talk about this. So what if you plug in a number here, like let's say 4, and you got 4 clusters, and you're like, wait, I want to go back to the default Polinsky criterion. Well, then just delete the number here. And it goes right back to automatic. Right? So automatic is giving us 2. So let's roll with 2 here and go forward. As before, let's save this variable here, the clusters variable. We call that fast food nutrition clusters or something like that. Let's see what I noted in my. Actually, I said in the slide I said call it health clusters. Let's call it health clusters. Let's rename that to be health clusters now. And within this, we're going to name our groups differently based on some criteria. So let's review quickly our clusters. Our clusters include 1 and 2, and let's see which one is the healthy of the two. So we're focusing on these two here. So if you read across clusters 1 and 2, you can notice across the board, cluster 1 is higher in every bad thing. Calories, saturated fat, cholesterol, sugar, total carbs, so on. So I think cluster 1 is our unhealthy, group of items. So I'll alias them accordingly. Edit alias here. Edit group, sorry. And cluster 1 is our unhealthy one. So we'll name that to be healthy. And 2 is healthy. Okay. Now I want to highlight one thing here before we move on, which is that bear in mind our we're clustering here based on menu items. So what we have really is the website fastfoodnutrition.com has provided us with a list of menu items. So we're grouping or clustering fast food menu items. Okay, so let's go on and go with fast food, call this fast food nutrition profiles. And we have here our health clusters, put them on columns out here. Now we can bring in our restaurants. So restaurants include, let's take a look at them. Arby's, Burger King, and the usual suspects. We'll bring restaurant onto rows. And so now we have this table created of health clusters and restaurant. It's bigger, so it looks nicer. And next I want to get a count of each of these. So how many items in Arby's menu are healthy versus unhealthy? So we'll drag ID over detail, and then we'll specify detail as being a count. Move count ID over to details. And so you can see now here that most of the items in Arby's menu are healthy, a little more, slightly more so than unhealthy, but in case of Chick-fil-A, that contrast is striking. So what if you now put count ID, convert this to a proportion? So let's say percent of total, and I'll say do percent of total here. So tell me of all the items they have, if you were to divvy it up into healthy and unhealthy, how would it stack up? So we kind of see out here some percentages showing up. We'll format them so they're easier to interpret. And that's what we have here. So we have here at Arby's, healthy is 53%, at Burger King 9%, Chick-fil-A is 9%, and so on and so forth. You can then kind of move count ID over to, let's say, color. You got a heat map out of this thing. And so kind of see out here, maybe use a color scheme that's green to gold or something. So high numbers are green, low numbers are yellowish. And so you can see here, we get this picture that tells us that Chick-fil-A by far is very, very green, and therefore more so telling us that we're seeing Chick-fil-A is compared to all of the restaurants here is the most healthy in terms of their menu. Subway that advertising healthy, 64% healthy items, which compares unfavorably to Taco Bell, which doesn't position itself as being a healthy restaurant, fast food restaurant. That's kind of interesting. Let's do one more kind of graph out here that might do a better job of bringing out the story. We could do a stacked bar chart, right? Let's see how we do that. Go to stack bar. So what if I get help clusters? Oops. Here. Let's move restaurant now. So help clusters onto color. You might get stack bar now, which is pretty cool, I think. Let's see if we can make this even cooler. So here you can see in this chart, you can see more clearly how the restaurants break out in terms of healthy and unhealthy. This I'm going to go with red and green. So healthy is is good, unhealthy is bad. So healthy items will just go with the color. So greenish sort of thing. So sort of green, and unhealthy is all kind of purple type thing. You can see out here in a sense that certain restaurants are kind of healthier than others, and so you kind of see here. What I'd like to do is to really flip the healthy and unhealthy here. Let's sort this here so that the unhealthy goes on top. Great. So you can kind of see here, the green part is really going to show us the fact that Chick-fil-A has lots of healthy options, and then other restaurants are less so than Chick-fil-A. Okay. And again, this is purely, I'm not promoting any of these restaurants, just kind of saying I don't eat meat, so most of these restaurants don't even appeal to me. But some of them do with their choices, but that's what the data is telling us in terms of their nutrition facts. Open this up a little bit more. And it's both percent of menu items. Okay, so with that being done, let's do a little bit more cleanup here. Maybe take the card away. We got a nice story coming out of running a cluster analysis on a bunch of nutrition facts of fast food restaurants. So let's do one more before we wrap up. We'll take a look at, we can look at some sort of this health data that comes with the World Health Indicators data set. We can also look at some interesting crime data. How about that? This is some crime data that the FBI provides. Unfortunately, data set is not up to date. The most recent data we have is for the year 2019, a long time ago. But let's take a look at what we can do with crime data. So nothing to do with marketing, but crime. So you can do crime, cluster crime in a sense by state. So, okay. It'll also give us some sort of a sense of one more aspect of Tableau, which is kind of handy, I think. So we're going to look at here all these state clusters, right? The cluster states, and we can do this for a data called crime. Crime is an Excel file, so I'll go to Excel here. So here's our crime data coming in, and our crime data is a mess. And here's why I wanted to go through this exercise, is because Tableau has some nice data cleaning capabilities to automatically clean your data up. So it sees null rows like this, it's going to clean them off because the data in its original form had all these table headers, which is typical in most Excel sheets people hand out. So data interpreter will take that away. And there's some other benefit things we can do out here to filter the data. The data here is for years 2018, 2019. We only want 2019. We only want it for states. So what I'm going to do is filter out anything that's not 2019 by adding a filter. Filter out here for year, and it will only keep 2019. So that's that. And then we'll set the filter up to also only keep states. So under area, we have here many places that are not states, like DC is not a state. And then we have in the bottom here all these different regions that are not states. So I'll check all the ones that I want to exclude, and then check the box for exclude. Right. Okay, so we now have excluded 16 of 66 values, leaving us with 50 states we want. Okay. All right, so with that being done, I think everything else in our data looks fine. I'll click now on state clusters. We'll make a quick and dirty clustering cluster solution out here. We'll take here okay, let's go over the data briefly here. So data includes information about crimes that the FBI, terms that FBI uses for crimes. So this aggravated assault rate per 100,000, burglary rate, larceny theft rate. We'll use these variables to cluster our data. So as such, our data now has, again, we're creating a scatter plot of aggravated assault rate and for 100,000 and burglary rate for 100,000. We'll rename the area to be a state. And then I'll drag state onto detail, so we get a dot for every state. We can verify that to be the case by hovering over any given state or dot. So it's New Mexico. Right. And we'll go to clusters before. I have this down by now, I know. But I want to make this out. Go to analytics, drag cluster over here to the right, and now we'll move a bunch of other variables we want to cluster also. So we have other crime variables here like larceny theft rate, motor vehicle theft rate, murder and non-negligent manslaughter, property crime rate per 100,000. We have rape revised definition, robbery rate per 100,000, violent crime rate per 100,000. I'll drag all these crime rates over to the right and make them all average. We'll see then how many clusters that Tableau is going to recommend to us. Because right now I have no idea what I'm expecting here in terms of clusters. So I'll go with the Tableau recommendation. Okay. Great. So I've done this for all the different variables, crime variables. We're running up with 2 clusters as the Tableau recommendation. Let's review the clusters, see what's in them. So here we have all our crime rates going in. Level of detail is state, normalized. Importantly, let's examine what these mean. So you'll go from left to right out here, you'll see that cluster 1 and 2 are evenly balanced. And the numbers on top seem to be higher across the board. So cluster 1 is seeing more aggravated assault, burglary, larceny, motor vehicle theft, murder, property crime, rape, robbery. So across the board, I'm seeing cluster 1 is having, so cluster 1 is like a bunch of high crime states, right? So we call this variable then state clusters. And we'll edit the groups to be, so that cluster 1 are, high crime. And second one is low crime. Again, relatively speaking, you can also see what's in the low crime states and the high crime states. Now, one really cool thing you have is you can now make a crime map. So we can now map out our clusters like literally in a geographical map by using the state variable. We cannot use it in its current form because state right now is string. But what if we told Tableau that state is in fact a geographical area called a state? It will then grab up the shape files for state, put a globe next to it, and we'll be able to examine a map of all the states in the United States. Now we have here 2 states, Alaska and Hawaii as well, and other states here. I tend to want to usually hide these. No offense to anybody from those states, but it's harder to interpret the map when you've got Alaska and Hawaii in there. So when you look at mainland United States, we can always bring Hawaii and Alaska back in a later point in time. Now, pan the map to make it center better. All right, now a key goal here is to be able to now map out crime in 2019. So this is our 2019 crime map. So state clusters is going to go on to color. And I will now use the option for marks of map. we'll take the state clusters, what kind of should I do that in there? Let's go and color these differently. So high crime, let's make it like some some color that suggests crime. So maybe not in favor of like a bright red, so go with like a pinkish red. And low crime would be sort of like more favorable, the nice looking color. I don't like vivid colors in general. In graphs, you don't want the colors to distract your attention. So, all right, so here's our map then. It tells us that the red are and that's not the political, association, any connection anyway to the political kind of connotations of colors. It's merely representing more crime then. So you see, series that are more red are kind of like higher crime. The ones that are green or bluish green are lower crime across the board. We have clustered states based on a bunch of crime variables and made a map out of it. I think that's pretty cool, right? Okay, we have gone over then a number of different examples of conducting cluster analysis using data on profit and sales to health concern variables to nutrition facts onto even crime. To sum up then, we began by looking at the purpose of segmentation, how cluster analysis is useful in conducting segmentation, the process underlying cluster analysis, a certain kind of clustering that's very popular called k-means clustering, and lastly, we conducted a number of exercises on clustering using Tableau. Thank you so much for joining me. Hopefully this was helpful.